Hey there, this is MathCamp321 presenting a short lesson on examples for Algebra Review number 2, which is solving system of equations by the elimination method. Here are the directions. Find the solution to each system of equations. Express any non-integer answers as improper fractions in lowest terms where appropriate. Write your final answer as an ordered pair. So before we get started, let's just review what an improper fraction is. An improper fraction, if it should appear, is a fraction that is top-heavy, meaning the numerator is larger than the denominator. We're just practicing making the connection between this vocabulary term, improper fraction, and what it actually might mean. I know in the last algebra review we worked on mixed numbers, just trying to get you to understand some of the different vocabulary associated with fractions. So let me give you a few examples of improper fractions. One might be, let's say, 9/5. Another improper fraction might be 13/10. Improper fractions can even be negative, maybe negative 8/3. But in all three of these examples, you'll notice that the numerator is larger than the denominator. Okay, anyway, let's take a look at system number 1. Negative 4x plus 7y equals 2, and 4x minus 5y is equal to 10. The first thing that you want to notice when you're doing a system of equations is whether the structure of the system is set up that everything is organized in columns. And I'd like you to take note of the fact that if we look downward, all the x's are lined up. And I'm going to do this with a faint yellow line. All the x's are lined up, all the y's are lined up, and all the numbers are lined up. So you want that preliminary step to have happened before you even start. And in this case, it's already set up that way. So all the x's are in a line, all the y's are in a line, and all the numbers are in a line. The next thing that you want to do is you want to decide on a variable to cancel out. And to decide which variable to cancel out, you want to look at the coefficients. So if you look at the coefficients of x, we have a negative 4 and a 4. And if you look at the coefficients of y, you have a 7 and a negative 5. And since we're trying to get variables to cancel out, I think negative 4 and 4 is the way to go, because if we add those together, they're just going to drop right out. So what I'm going to do is draw a line underneath this system, and I'm going to put a plus to indicate that I'm going to be adding, and I'll put that in a circle because there's this number 1 is there. And I'm just going to add down these columns. Now, negative 4x and 4x are going to cancel out. 7y minus 5y is 2y. 2 plus 10 is 12. Now I'll divide both sides by 2. When I do this, the 2's will cancel out, and I get y equals 6. Now that I've got y, I need to back substitute into one of my original equations to solve for x. So let's look back to our original equations and figure out which one might be the easiest to work with. They both seem about the same level of difficulty, but I think I'm going to use the bottom one. So I'm going to just draw a quick little arrow over here, and I'm going to say 4x minus 5 times blank is equal to 10. Now the blank represents y, and we just found a moment ago y to be 6. So 6 is going to be substituted into that blank. Now simplifying this, we'll end up with 4x minus 30 equals 10. I'll now add 30 to both sides. In doing this, the negative 30 and 30 will cancel out. So now I'm left with 4x equals 40. Dividing both sides by 4, the 4's will cancel out. So I'm left with x equals 40 divided by 4, or x equals 10. Now, the directions say to express our final answer as an ordered pair. So I'm going to write these in alphabetical order. X comes before y, so I'm going to write the ordered pair 10, 6. So the ordered pair 10, 6 represents the solution to our first system of equations. Let's go to number 2. As I look at number 2, the first thing that I want to notice is whether everything is structured in the right way. Are all the x's lined up vertically? Are all the y's lined up vertically? Are all the numbers lined up vertically? And the answer is yes. And I'm not going to use the yellow pen this time because I think it just kind of made it a little bit harder to read. So now I want to figure out which variable is going to be easier to cancel out. And I'm honing in right away on the y's because I've got a 7y and another 7y. Ideally, one of the 7's would be positive and the other would be negative. But that's actually a quick fix. What I can merely do is I could subtract the bottom row from the top row. So like the first one, I put a big plus on the outside. Now I'm going to put a minus on the outside. And maybe what I'll also do is I'm not just subtracting one thing, I'm subtracting the entire bottom row. So I'm going to put the whole bottom row in parentheses. Okay, now subtraction always gives students a bit more difficulty than addition, seriously. So let's go a little bit slow. What is 6x minus 2x? Well, the answer is 4x. Now, what is 7y take away 7y? Well, anything take away itself just gets eliminated, so that's just going to go away. Now we have our equal sign, and now be very careful on this final maneuver. What's 4 minus a negative 12? Well, from your Algebra 1 class, minus and negative becomes plus, so 4 plus 12 is 16. And now I'll go ahead and divide both sides by 4. The 4's will cancel, and I'll be left with x equals 4. Because 16 divided by 4 is 4. And now I need to back substitute. So again, let's take our answer of x equals 4 and plug it into either the top or the bottom equation. The top one looks just a little bit easier to work with. The coefficients seem smaller and more manageable. So I'm going to say 6 blank plus 7y equals 4. Now that blank represents x, but we just found x a moment ago, and x is equal to 4. Simplifying, I get 24 plus 7y is equal to 4. Okay, so I want to isolate y, which means I want to get y by itself. So let's next subtract 24 from both sides. Okay, in doing this, the 24 and the negative 24 will cancel, and we'll be left with 7y is equal to negative 20. And to isolate y completely, we'll divide both sides by 7. The 7's will cancel, and I'll be left with y equals negative 20 over 7. This is a top-heavy fraction. It can't be reduced. So I'm just going to leave it as y equals negative 20 over 7. So our final answer, if we're to express it as an ordered pair, is going to be 4 negative 27ths. It's really important that you put an ordered pair inside of parentheses. I know in past years when I've graded these, some students don't write the ordered pair in parentheses, and that is the proper notation for ordered pairs. So please do that. So here are your first 2 examples, your first 2 out of 6. So in a moment, we're going to be shifting to the second slide where they're going to get a little harder. Okay, so we're on example 3 of solving system of equations by the elimination method. The first thing I notice about number 3 is that we are not in the structure that we want. Usually it's been x's and then y's and then an equal sign and then a number. And while that happens for our second equation, the first equation does not subscribe to that. So the first thing that I'm going to need to do is rearrange or manipulate that top equation so that it form fits to our structure that we want. So I want to get the 5x to the other side of the equation. So when you move something across the equal sign, it ends up becoming opposite in sign. What that means is if it was positive, it will become negative, and conversely, if it were negative, it will become positive. So take a moment and think about what that new top row will be if I move the 5x over the equal sign to the left. It's going to end up being negative 5x plus y equals negative 3. Now the bottom row is already form-fitting to our structure, so I'm just going to write that over again and not do any manipulations. Now, systems are usually denoted with a brace on the left-hand side, and some kids are just not very good at this, so give it your best shot at making a brace. That was pretty good. And now you want to assess which variable looks easiest to cancel. And I'm being just drawn right into those y's. There's a plus 1 and there's a minus 1, and they're just going to drop out if we add. Okay, so let's set up for some addition. Okay, negative 5x plus 8x is 3x. The y and the negative y will cancel out. And negative 3 plus 9 is 6. I'll now divide both sides by 3. The 3's will cancel out. And I'll be left with x equals 6 over 3 or x equals 2. Now I need to substitute or back substitute into one of the initial equations to get y. And I think the top equation is really set up for that right now. So I'm just going to draw a little arrow here. And I'm going to say y is equal to 5 blank minus 3. Now the blank represents x, and we just found x to be 2. So I'm going to substitute 2 into the blank. And now I have y equals 10 minus 3. And of course, y would equal 7. Expressing our final answer as an ordered pair, we get the ordered pair 2, 7 in parentheses. Okay, let's go to example 4. In example 4, the first thing that I observe is that the structure that I want is already in place. All the x's come first, then the y's, then the equal signs, then the numbers. So the next thing that I want to do is figure out which variable will be easiest to cancel. So the numbers in front of the x's are 4's and 2's, and the numbers in front of the y's are 3's and 1's. Neither is a bad option, but I'm thinking I like the y's better. That top row has a coefficient of positive 3, and it would be awesome if the bottom row had a coefficient for y of negative 3. So to make that happen, it's going to require multiplying the entire bottom row by positive 3. So watch how I do this. And now you have to denote it in some way so that the reader and even yourself, you know what you're doing. So I'm going to partition this whole bottom row off with a set of parentheses, and I'm going to put a 3 on the outside. I'll even put it in a little circle. Now, the top row, I'm not doing a thing to. I'm just going to rewrite it. So 4x plus 3y is equal to negative 9. But the bottom row, I'm going to distribute the 3 through each and every term from beginning to end. The 3 is going to be multiplied by 2x. The 3 is going to be multiplied by negative y. And the 3 is going to be multiplied by 3 at the end. So make sure you grab all of those 3 terms. So 3 times 2x is 6x. 3 times negative y is negative 3y. And 3 times 3 is 9. Now it's time for everyone's favorite maneuver, and that is to include your brace. Make it amazing. Amazing brace. Now that one wasn't bad. Okay, so I'm going to draw my line. I'm going to put a plus outside of the system. And I'm just going to add downward. But the first thing I observed is that the 3y and the negative 3y are going to cancel out. So I'm left with 4x plus 6x, or 10x, is equal to negative 9 plus 9, which is 0. I'll divide both sides by 10. 0 divided by 10 is 0. And now I need to plug that into one of my equations from the beginning to solve for the corresponding value of y. I'm going to use the top row just because it seems like I haven't really messed around with it too much. I'm just going to come down here and make one of my fancy little arrows. And this is going to be 4 blank plus 3y equals negative 9. Now the blank represents x, and we found x to be 0. 4 times 0 is 0, so we have 0 plus 3y is negative 9. Well, 0 plus anything doesn't really contribute anything to the overall sum, so it's just 3y. I'll divide both sides by 3. 3's will cancel. And I'm left with y equals negative 9 over 3, or y equals negative 3. So expressing my final answer as an ordered pair, I get the ordered pair 0, negative 3. Don't forget to write it inside of parentheses. Okay, hang tight for the last slide where there are 2 final examples, and they will be the hardest of all, so don't tune out now. Really pay attention to the last 2.